Hello everyone, I'm SRAVYA from IIT Roorkee, first year DSAI. Welcome to my presentation on a C++ calendar application. In this project, I have implemented a small application that allows the user to input a specific month and year to display a formatted calendar. Throughout this presentation, I'll take you step by step through the code, explaining how each part contributes to the final result. The goal of this calendar application is simple. It is to display the days of any given month and year. It shows the days starting from the correct weekday, taking into account things like leap years which affect the length of February. This project is an example of how C++ can be used to create practical tools with an emphasis on modular programming and clean code. Before diving into the code, let us go over the key features of this application. The first key feature is leap year calculation. We need to determine if a year is a leap year since that changes the number of days in February. The second key feature is days in each month. The program correctly handles the different number of days in each month, which varies from 28 to 31. The third key feature is start day calculation. Using a formula called Zeller's congruence, we can accurately calculate the starting day of the month, ensuring the days align with the correct weekdays. And finally, the program outputs a well-formatted calendar where the days are printed in the correct positions across the weeks. Here's an overview of the structure of the code. The program starts by including two important libraries, IOStream for input-output operations and IOManner for formatting. The program then declares several functions that handle different parts of the logic, such as checking for leap years, determining the number of days in each month, and calculating the first day of the month, and displaying the entire calendar. The main function coordinates these different tasks, taking user input and using the functions to generate and print the calendar. Let us take a closer look at the first function, isLeapYear. Leap years happen every 4 years but with a few exceptions. The rule is a year is a leap year if it is divisible by 4, except if it is divisible by 100 unless it is also divisible by 400. In the code, the function checks these conditions. First, it checks if the year is divisible by 4. If so, it then checks if the year is not divisible by 100 unless it is divisible by 400. If all these conditions are satisfied, the function returns true, indicating that it is a leap year and February will have 29 days. Otherwise, it returns false, meaning February will have 28 days. This function is crucial for correctly handling the calendar in leap years, especially for February. Next, we have the getDaysInMonth function. This function takes the month and year as input and returns the correct number of days in the specified month. It uses a switch statement to match the month with its corresponding number of days. For example, January has 31 days, February has 28 or 29 depending on whether the year is a leap year or not, and April has 30 days and so on. The case of February is special because it uses the isLeapYear function we just discussed, and this ensures that the correct number of days are returned for February based on the leap year status. The next key part of the program is the getStartDayOfMonth function. This function calculates which day of the week the first day of the month falls on using a mathematical method called Zeller's congruence. Zeller's congruence is a formula used to calculate the day of the week for any date. The formula accounts for months, days and years to return the day of the week, where Sunday is considered as day 0, Monday as day 1 and so on. Here is how the formula works. If the month is January or February, we treat them as the 13th and 14th months of the previous year. This is to align the year with the formula. We then calculate two values, k which is the last two digits of the year and j which is the century part of the year. Using the formula, we compute the first day of the month to the day of the week. Now that we have determined the first day of the month and the number of days, the display calendar function takes care of the formatting and printing the calendar. Here is what this function does. First, it prints the name of the month and the year at the top of the calendar, which makes it clear which month is being displayed. Then it prints the days of the week, Sunday through Saturday, on a single line as headers. After that, the function calculates how many empty spaces should be printed before the first day. For example, if the month starts on Tuesday, the function prints spaces under Sunday and Monday. It then prints each day of the month in its correct position. Every time the day reaches Saturday, it starts a new line for the following week. This ensures that the calendar is well formatted and is easy to read. And finally, the main function. The main function is where the user interacts with the program. It asks the user to input the month and the year for which they want to see the calendar for, and after receiving the input, the function calls display calendar with the user's input to print the calendar for that month and year. If the user enters an invalid month, like a number less than 1 or greater than 12, the program will display an error message and stop running. Otherwise, it will proceed to display the calendar. Let us look at an example of the output. If we input 2007 June, the program will print a calendar that starts on a Thursday. The days will be displayed in a row under the correct weekday with all the weeks lined up properly. The function handles this for any month and year that the user inputs, and the output is formatted neatly. To conclude, the C++ calendar application is a practical example of how programming can be used to generate real-world tools. We broke down the problem into smaller parts using functions to handle each task such as leap year calculation, day counting, and formatting. By keeping the code modular and organized, this application can easily be expanded to include new features like event managers or even a graphic user interface. Thank you for listening, and I hope this walkthrough of the code has been insightful.